Guys. So today I'm actually going to forego the PowerPoint presentation since it's going to be going over some very simplistic things. So I just wanted to talk to you this way. So we're going to talk about how Java works with arithmetic. Not every language is exactly the same, and Java follows normal math compared to some of the other languages that I have to work in that don't follow normal math. But in the arithmetic for Java, it works with the PEMDAS system, parentheses, uh, emphasis, or whatever goes up top. I think it's called emphasis. Multiplication, division, addition, subtraction. It follows that order. There are other languages out there that do not follow that order. Currently, I work in a language called MUPS. That language does not follow that order. That follows the left to right, which means no matter what you're doing, it will calculate the math left to right. And it does that, and we have to prepare for that. We specifically have to put everything that we want to go first, everything that should happen first, go first. We have to create our own PEMDAS system that way, in the left to right order. So let's jump on over to the code. All right, guys, so here we are at the code. We're going to be here in the code for a bit of time. Not all too long. We're going to go over some really simple arithmetic so you guys can start creating your own arithmetic programs. So I'm just going to add another class to the Learn Java 101, which we go into class. I'm going to give it a main method, and I'm just going to call it arithmetic. Hopefully that's spelled correctly. If it's not, oh well. So as we see here, I'm just going to create some simple statements. And since these statements can print out really anything, but it calculates everything that goes on in the first place first, since if you were to put in a variable, it'll pull in the variable's value. In this case, it'll also do the math for us. So if we do 9 times 3 plus 2, as you can see, the spacing isn't actually how it's supposed to be. 9 times 3 is very close together. If I right click, and I think it's in refactor, source, format. It formats it to how code should be written. So if you ever need to do that, just always hit right click, go to source and format, or you can do Control-Shift-F as a short thing. I always do the toggle comment because I prefer to comment that way rather than having to type in all comments. So if I were to run this, if there's hopefully there's like an easier way to run this. I get 29. So the way this goes is 9 times 3 is 27 plus 2 is 29. Now if I were to reverse this by also doing 2 plus 3 times 9, this should also equal 29. Since it does the PEMDAS system, you have 9 times 3, 3 times 9. That works first because you have multiplication. Then it does the addition afterwards. A way that we can get around this is adding parentheses around 2 plus 3. So we make sure that it'll be 5 times 9, the way that I want it to be. And I'll get 45, because 2 plus 3 is 5, times 9 is 45. So this works that way. When you start adding in additional things such as square roots or to the powers, we'll be using the math dot class. So math dot pow of 2 to the second power plus 4. 2 to the second power is 4, and plus 4 equals 8, which is equivalent to 2 to the third power. So I should get 8.0. Now, since we're using the math class of Java, which is a math library, which has a bunch of different things in it. It also has statics. So if I do math dot, and I have no default proposals. Why don't I have default proposals? Well, if I do math.py, this is a static. Still no default proposals because my IntelliSense must be broken. But there's a lot of different things in here where you have square root, you have math.py. Everything in here returns as a floating point. So if we see here, up here, 9 times 3 plus 2, 2 plus 3 times 9, 2 plus 3 times 9, all in parentheses. And then once we get to math.pow, you can see the differences. Well, here we're working with pure integers. Therefore, our result is a pure integer. The compiler just assumes that it's going to be an integer. Therefore, we get an integer. But once we go with math.pow, we're getting a double. And if we add 4 to that, which is an integer, we still want to keep this floating point. So it assumes or typecasts this 4 to a double for us, and then adds it. But since we added the math.pow or math.py constant, we can run it and it'll print. Now I could also do this out. I want to do math.square root on a math.pow of 2 to the 2 plus 8.5. So this should return, or is the mathematical equation of the square root of 2 squared plus 8.5, which should be 10.5. Since I'm taking the square root of 2 squared, so therefore I just take 2, I get rid of the squaring power and cancel them out, should be 10.5. That's what we get. A way to typecast this very simply to a double is to add a .0 plus 5. That will typecast it to a double or to a float. So I get a 15.0 double. That's an easy way to typecast. Now, since this is very simple arithmetic, I just wanted to show you guys that Java does this in the PEMDAS system. I don't have the programming language that I work in for work, bumps, on my computer or on my personal computer to show you that it works from left to right. But there are other languages out there that do not follow the normal arithmetic that you learn in school, which is the PEMDAS system. Instead, they will do left to right, right to left, or they'll do their own generative math assignment to them. Because you can go in and create your own math. You'd have to do a bit of work, but you can create your own math. Now, that's everything I wanted to go over today. Thank you guys very much. See you guys next time.